Hello, everyone, and welcome to our session on understanding a critical dichotomy in software engineering, latency versus throughput. As developers, team leads, or architects, you constantly make decisions that impact system performance. But are you optimizing for the right metric? Today, we'll demystify these two fundamental concepts, explore their distinct characteristics, and discuss the crucial trade-offs involved in system design. We'll start by defining each term, then delve into their relationship and when to prioritize one over the other. By the end, you'll have a clear framework for making informed performance decisions in your projects. Let's dive in. Let's begin with latency. Simply put, latency is the delay before a transfer of data begins following an instruction for its transfer. Think of it as the time it takes for a single operation to complete from start to finish. For example, when you click a link on a website, the time it takes for your browser to receive the first byte of the server's response is a measure of latency. It's often measured in milliseconds and is a key indicator of responsiveness. High latency means things feel slow and sluggish. In networking, common examples include round-trip time. Round-trip time, or TT, is the time taken for a signal to go from sender to receiver and back, or the processing delay within a system component. Minimizing latency is crucial for real-time applications, like online gaming or video conferencing, where even small delays can significantly degrade user experience. Now, let's turn our attention to throughput. Unlike latency, which focuses on a single event's duration, throughput measures the amount of work a system can handle over a given period. It's about quantity, not speed for a single item. Imagine a highway. Latency is how long it takes for one car to get from point A to point B, while throughput is how many cars can pass through a specific point on that highway per hour. In computing, throughput is often expressed as requests per second, data transferred per second, or transactions processed per minute. For instance, a database's throughput might be 10,000 queries per second. High throughput is vital for systems that need to process large volumes of data, or many concurrent requests like e-commerce platforms during a sale or big data processing pipelines. It's about maximizing the total capacity. So, how do latency and throughput relate? It's crucial to understand they are not interchangeable, though often confused. They're independent metrics, meaning you can have high throughput with high latency or low latency with low throughput, and vice versa. Consider a very wide but slow highway. Many cars can pass, high throughput, but each car takes a long time to travel, low latency. Conversely, a very fast single-lane road might get one car through quickly, low latency, but can't handle many cars simultaneously, low throughput. Optimizing for one often impacts the other. For instance, adding more parallel processing units might increase throughput, but could also introduce coordination overhead, potentially increasing latency for individual tasks. The key is to understand which metric is most critical for your specific use case. Understanding the trade-offs is where system design truly shines. You can't always maximize both latency and throughput simultaneously. The decision depends entirely on your application's requirements. For real-time interactive systems like online trading platforms or live video streaming, low latency is paramount. Users demand immediate feedback. Conversely, for batch processing jobs like nightly data analytics or email campaign distribution, high throughput is usually the priority. It's about processing a large volume efficiently, even if individual items take a bit longer. Common optimization strategies include caching to reduce latency, or using parallel processing, load balancing, and asynchronous operations to boost throughput. Remember, there's no single best approach. It's about finding the right balance for your specific system goals. To summarize, we've explored latency as the time for a single operation and throughput as the amount of work over time. They are distinct metrics, and understanding their relationship and trade-offs is fundamental to designing efficient and responsive software systems. Always consider your application's specific needs before deciding which to prioritize. Effective system design often involves a delicate balance, and continuous monitoring and optimization are key. As a next step, I encourage you to analyze a system you're currently working on. Identify its primary performance bottleneck. Is it latency bound or throughput bound? And what specific optimizations would you consider to improve that particular metric? Thank you for joining.